Hello and welcome to G Fun Facts Online, the place where we dive deep into the most fascinating corners of our world. I am your host, and today we're literally going deep beneath our feet, in fact. We're exploring the largely unseen dimension of human history, a world of forgotten structures and lost passages. Get ready to journey into the depths as we uncover the secrets of subterranean archaeology. So, why do we bother digging deeper? Why this allure of the underworld? Well, these forgotten underground structures aren't just holes in the ground. They are incredible time capsules. Think about it: the intricate catacombs of ancient Rome, the mind-boggling subterranean cities of Cappadocia like Derinkuyu, which we'll talk more about later, or even hidden military bunkers, ancient Connaught water systems, and forgotten basements right under our modern cities. These spaces tell us so much about how past societies adapted, protected themselves, conducted rituals, or managed vital resources. And here's a cool part: the unique conditions underground often preserve delicate artifacts, things that would have vanished on the surface. It's like getting an exceptionally clear window into the past. Okay, so how do archaeologists even find these hidden realms? It's not always about grabbing a shovel straight away. The search often starts with some serious historical detective work, poring over ancient texts, old maps, and even local folklore. These can hold tantalizing clues. Then, it's time for the high-tech eyes in the sky and on the ground. Satellite imagery and aerial photography can reveal subtle clues on the surface, like weird vegetation patterns or soil marks that scream something's buried here. And then there's LiDAR, light detection and ranging. This tech, often deployed from planes or drones, shoots laser pulses to create super detailed 3D maps. LiDAR can literally see through dense forests, revealing ground features invisible to us. It's a game changer. But the real workhorses for seeing beneath the soil without digging are geophysical surveys. It's like X-raying the Earth. First up, ground-penetrating radar, or GPR. It sends radio waves into the ground and reads the reflections. Different materials and empty spaces reflect waves differently, letting archaeologists map out walls, foundations, or even hidden cavities. Some GPR systems can even give real-time 3D visuals. Then there's magnetometry. This measures tiny changes in the Earth's magnetic field. Things like old hearths, kilns, or buried iron objects create magnetic blips. Electrical resistivity tomography, or ERT, passes an electrical current through the ground. Stone walls conduct electricity differently than, say, moist soil in a pit, helping create a subsurface map. Electromagnetic conductivity, or EM surveys, are similar, often faster but with a bit less depth. And sometimes the past just bursts into the present. Construction projects or even farming can accidentally unearth these forgotten structures. That's how Derinkuyu in Turkey was found. A man knocked down a basement wall and bam! An underground city. Once a potential site is ID'd, the investigation kicks into a new gear. This might start with minimally invasive probes, like drilling small boreholes to get soil samples, or digging small strategic test pits for a first peek. When it's time for full excavation, it's all about precision and care. Modern archaeology tries to be as minimally destructive as possible, targeting specific areas. And safety is huge. Underground digs can be dangerous. Think structural collapse, bad air quality, or even flooding, so robust safety protocols are a must. Documentation is the absolute cornerstone. And in the digital age, it's incredible. 3D laser scanning and photogrammetry capture millions of data points to create hyper-accurate 3D models of these complex spaces, even in the dark. Imagine having a digital twin of an ancient tunnel. For tiny or dangerous spots, borescopes, tiny cameras on flexible tubes, or specialized robots can go where humans can't. But don't discount the classics. Detailed notes, sketches, and photos are still vital. Then comes the deep analysis. Stratigraphic analysis, studying the layers of soil, helps create a timeline. Material analysis of things like mortar or bricks reveals their origin and age. And artifacts found within pottery, tools, organic bits tell the story of what happened there. Dating techniques like radiocarbon dating for organic stuff and optically stimulated luminescence for sediments pin down the age of the structures. Archaeologists even reconstruct ancient environments by analyzing pollen, animal remains, and sediments found inside these structures. It's like building a complete picture of the past, above and below ground. Now, going underground isn't a walk in the park. Subterranean archaeology faces some serious hurdles. Access can be tricky and dangerous. Think confined spaces, total darkness, unstable structures, and hazardous gases. Yikes! Preservation is another big one. While some underground spots are amazing for preservation, others can be really harsh due to humidity or soil chemistry. Water inundation is a common problem, flooding ancient structures. Plus, all this specialized tech and expertise, it's expensive. And, super importantly, many sites, like catacombs or tombs, contain human remains, demanding incredibly sensitive and ethical handling. But the discoveries? They are breathtaking. We mentioned Derinkuyu in Turkey. This massive, multi-level underground city could house up to 20,000 people. It was accidentally rediscovered in 1963, and its exploration is still blowing minds. The Roman catacombs. Geophysical surveys and 3D laser scanning have massively boosted our understanding of these vast burial networks without disturbing anything. And get this, LiDAR technology has helped uncover thousands of previously unknown Mayan structures, palaces, defensive walls, entire neighborhoods hidden under dense jungle in Central America. It's completely changed our view of Mayan civilization. More recently, GPR and ERT surveys near the Giza pyramids have flagged a significant subsurface anomaly. Could it be unknown archaeological remains? The investigation is ongoing. Even Leonardo da Vinci gets in on the action. His sketches, combined with GPR and 3D scanning, helped verify hidden passageways beneath Sforza Castle in Milan. How cool is that? So, what's next for subterranean exploration? The future is incredibly exciting. Think advanced robotics and AI. Autonomous robots navigating and mapping tight underground spaces, with AI sifting through massive datasets to spot anomalies humans might miss. There's even a fully autonomous GPR robot called AutoMira in development. Imaging tech will only get better. Higher resolution, greater depth, maybe even multispectral LiDAR that tells us about material properties. And imagine virtual and augmented reality. We're already using VR/AR to create immersive reconstructions for research and to show the public. It can even help with analyzing the stability of these ancient structures. Plus, there's a huge push for non-destructive analysis, preserving these fragile records for generations to come. Subterranean archaeology is just this captivating field, isn't it? It peels back the Earth's surface to reveal these forgotten chapters of human history. Using everything from old-school historical research to cutting-edge remote sensing and 3D modeling, archaeologists are literally charting these hidden landscapes. The challenges are immense, but the rewards, understanding our ancestors' ingenuity, their resilience, and the complex worlds they built right under our feet, are just immeasurable. And as technology keeps leaping forward, the quest to discover and analyze these forgotten underground structures promises to unveil even more astonishing secrets from the depths. That's all the time we have for today on G Fun Facts Online. Join us next time as we unearth more amazing stories from our world. Thanks for listening.